Welcome back to the deep dive. Today, we're taking on a really massive foundational topic, the critical necessity of AI governance and program management. We're all seeing this technological shift that promises, well, unprecedented value. We're talking about hyper efficiency, complete process transformation, and a huge competitive advantage. But here's the central tension, right? The friction point we saw laid out in all the source material. This incredibly rapid pace of development, the need for these huge amounts of data, and all the unpredictable ethical and security challenges. It just means enterprises are facing governance problems they have never, ever encountered before. So if you want to use AI responsibly and safely, governance isn't just a checklist anymore. It's really the core strategy that ensures the value proposition actually happens.
That's absolutely the mission here, yeah. We've got a stack of sources that show us exactly how strong governance can make sure AI systems drive that business value while, simultaneously protecting the enterprise's most critical assets. We're talking their data and, maybe even more importantly, their reputation. And this whole process, it's not about throwing out your existing frameworks. It's really about adapting those existing InfoSec structures and building entirely new ones to handle the ethical and security risks that are totally unique to AI.
Okay, so let's start with the basics. The definition. AI governance is, senior oversight, processes, standards, safeguards that ensure the safe and ethical use of AI systems. But the most insightful nugget I found here is that governance isn't just about protecting against, say, external threats. It's about mitigating the inherent flaws that come from the human element in creating AI.
Precisely. AI models are still a product of code and machine learning developed by human teams, and that makes them highly susceptible to human biases, to human errors that can lead to discrimination or some kind of unintended harm. Governance provides that structured approach to mitigate that risk. It focuses on transparency, explainability, and really strong data quality checks to build that overall trust in what we call responsible AI usage.
I think the sources gave a perfect example of why human intent just isn't enough for an AI system. If a person tells another person, hey, defer payment of the credit until after the holidays, that instruction is, crystal clear in a human context.
Right. But for an AI system,
Yeah.
that instruction is way too vague. It doesn't know what the holidays means in a transactional sense. Does the user mean the next federal holiday or December 25th? That simple example just underscores the need for algorithmic precision and the need for explainability. If the AI system denies that deferral, the company needs to understand exactly how the system got to that result to ensure fairness and, well, to make sure it's working right.
So, if explainability is the how the system works, the real question becomes who is accountable for the outcome? And that means mapping out the specific roles involved in the AI lifecycle, starting at the top with leadership. We saw in the research basically four categories. Leadership and strategy, that's your chief AI officer setting the vision. Developmental and operational, your data scientists and engineers building the solution. Then you have the users, employees, and consumers. And finally, governance and oversight, which might be an AI steering committee.
And the crucial insight here for leadership is that accountability for the consequences of AI adoption cannot be delegated. The governing body isn't responsible for the inner workings of the complex system itself, but they are 100% responsible for the outcome of its use, which means they have to understand the risks involved.
Which brings up a really fascinating and I think dangerous pitfall they have to avoid, the risk of anthropomorphizing the AI.
Oh, this is critical. Yeah. Anthropomorphizing means wrongly treating the AI as if it were human, attributing characteristics like thinking or judging or having a moral compass to the system. The moment you start trusting the AI to have intent or some kind of moral judgment, you stop vetting its results. And that's a massive failure of governance because the AI is a mathematical probability engine, not a moral agent. Leadership is still legally accountable for its output, period.
So to structure that accountability, you need to know who your stakeholders are. Internally, you've got senior leadership. They're concerned with strategy alignment and managing the risk of failure or, reputational harm. Employees need training so AI truly complements their workflows. IT teams obviously require secure infrastructure and, most importantly, high data quality.
And externally, you have customers who are demanding privacy and protection against bias in the outcomes. You have regulators naturally demanding adherence to all the new laws coming out. And society as a whole is now a major stakeholder. They're requiring social responsibility, including considering the environmental impact of these incredibly resource-intensive systems.
Okay, building on that foundation, let's move into strategy. It seems clear that proactive AI strategies, whether we're talking national, industry, or corporate, are essential, not just to align with values, but to secure a real competitive advantage. We saw the OECD AI principles referenced again and again as a fantastic guide, focusing on those key ethical concepts: fairness, transparency, robustness, and accountability.
And when an organization decides to implement an AI solution, they face two core strategic choices. You've got the classic build versus buy dilemma. And then, coupled with that, the hosting choice, internal versus cloud.
Let's talk about those hosting trade-offs because they transfer risk in a really significant way. If you host internally, you get more control, you get better customization, and it's easier to control data security and privacy. But all that control comes with massive costs, higher resource requirements, increased power consumption, and the immediate need to go out and hire or train new, highly specialized skill sets.
Right. And conversely, hosting in the cloud offers that immediate better scalability, less operational overhead, lower upfront costs.
Sure.
But you introduce a fundamental risk transfer. Things like vendor lock-in, performance concerns due to network latency, and critically increased data security and privacy concerns because your crown jewel data is now leaving your controlled environment. So if you buy a solution or host in the cloud, that oversight of your vendors is just essential. You have to vet them on their ethical adherence and how well their AI strategies align with your own corporate values.
In moving from strategy to ethics, the topic of bias and fairness is just so critical. I mean, it directly impacts your reputation and your legal liability. What does the NIST framework tell us about how to categorize the complex root causes of bias?
NIST breaks it down into three main categories: systemic, statistical, computational, and human. The examples of systemic and statistical bias are truly stark because they show that AI doesn't just mirror bias, it turbocharges it. It makes existing human flaws exponentially harder to root out.
How so? Can you give us an example of that systemic bias?
Yeah, systemic bias results from institutional procedures that already favor one group, and the AI just learns that procedure. The 2018 example of Amazon's AI recruitment tool is perfect because their historical hiring data was biased. It favored male candidates. The algorithm essentially just amplified that existing pattern. It systematically downgraded female candidates without any human telling it to do so. The bias was structural, not technical.
And statistical bias, that comes from errors when the data sample isn't really representative of the population.
Exactly. This is a failure of data diversity. The classic finding from research that same year showed that facial recognition systems from major companies had an error rate of just 0.8% for white men. But that error rate shot up dramatically to 34.7% for black women. That is a direct, quantifiable result of unrepresentative training data. The biggest challenge for a team trying to fix that is just getting the resources to constantly vet and expand those training inputs.
And beyond bias, you have these massive intellectual property concerns. The sources highlight this ongoing debate and litigation over the uncertainty of copyright ownership for Gen AI-created content. Tell us a bit about the core conflict in that Anderson v. Stability AI litigation.
Well, that suit, and a lot of others like it, they deal with a fundamental conflict. Developers of these generative models scraped billions of images and text from the open web to train their systems. And these scraping processes often included copyrighted material. So the question the courts are struggling with is whether the resulting output art, code, or text is a derivative work that infringes on the original owner's IP, or if that initial scraping was fair use. Companies need governance policies now to clarify who owns the content created by their internal AI users. It's a mess.
And we really cannot discuss the ethical impacts without addressing the environmental footprint. This was a surprising fact for me. AI is extremely resource intensive. One piece of data we saw showed the International Energy Agency found that a single ChatGPT request consumes approximately 10 times the electricity of one traditional Google search.
10 times. That's just staggering. And it connects to the overall trend of data centers consuming massive amounts of power globally. For listeners in Europe, just think about Ireland, where data centers are estimated to account for nearly 35% of the country's entire energy use by 2026. This isn't just an external issue anymore. Organizations adopting AI need specific internal strategies to strive for energy efficiency and sustainability just to meet stakeholder expectations.
So how do we operationalize all this governance? The mechanics seem to start with knowing exactly what AI assets you have. An AI asset and data inventory is paramount, and this is where AI systems, or AIs, are fundamentally unique compared to traditional IT assets.
Yeah, an artificial intelligence solution is so much more complex than just a standard application. A single AIS might have multiple owners across different departments, different models and versions, various data sets for both training and production, and multiple specific algorithms running inside it. The inventory's goal here is not to punish employees for using unsanctioned shadow AI, but to identify everything that's in use so you can increase governance and risk management across the enterprise's entire AI estate.
Right. And once you know the assets, you have to focus on the data itself because that is where the whole system stands or falls. Data quality is absolutely paramount. And the sources connect one of the biggest problems with Gen AI directly to the data,
Yeah.
hallucinations.
Hallucinations, those false or just nonsensical AI outputs, they're almost always linked to data issues. Training data that is biased, incomplete, incorrectly labeled, or just irrelevant.
Mm.
Unlike conventional software development, which is all about code logic, AI development is entirely dependent on high-quality data to teach the model. And that led to the creation of the famous 5 V's of big data.
We hear the 5 V's listed a lot: volume, velocity, variety, veracity, and value. But why are they so crucial in the context of AI governance and hallucination risk?
Well, veracity is the key V here. It's the measure of truthfulness and accuracy in the data. If the data lacks veracity, if it's inconsistent, dirty, or outright wrong, the model is going to learn those inaccuracies, and the output will be a hallucination. So governance has to focus on securing veracity right at the source. And when high-quality consented data is scarce, organizations have to resort to mitigation strategies.
What does that mitigation look like in practice?
It looks like augmentation, which means procuring missing data or even generating synthetic data that mimics the necessary distribution without the privacy concerns of real-world data. Or it means ensuring appropriate model selection, so choosing an AI model that works efficiently with the actual size and variety of the data set you have to avoid overfitting or underfitting.
Now, let's clarify a critical distinction that security teams often miss when they start drafting security programs. Security for AI versus AI for security.
This distinction is absolutely vital. Security for AI is all about protecting the AI system itself, the models, the training data, the prompts, and the infrastructure against these unique attacks. So, for example, defending against a prompt injection where an attacker tricks the AI model into overriding its safety instructions and leaking sensitive data, it's about ensuring the AI functions as intended.
Okay, and the other side of that coin, AI for security.
That's the incorporation of AI technology to enhance traditional security processes. For example, using an AI algorithm for advanced threat detection that spots subtle anomalies in network traffic that a human analyst would probably miss, or prioritizing vulnerability patching based on real-time risk scoring. Both have to be managed under a cohesive AI security program, but they require totally different skill sets and defense mechanisms.
Let's talk about when things inevitably go wrong, starting with the unique challenge of an AI incident. Traditional systems fail when a rule is broken. It's a hard error, but AI operates based on mathematical probability, meaning incorrect predictions actually occur by design some percentage of the time.
And that probabilistic nature makes establishing an incident threshold incredibly challenging for governance teams. You need clear performance metrics and an acceptable error baseline. Without them, how do you know if a wrong prediction is just a minor feature of the probabilistic model or a bug or the result of a malicious attack like data poisoning? It's really hard to tell.
We noted 3 common AI-specific incidents that require these tailored responses. Adversarial attacks, so manipulating input to deceive models. Data poisoning, which is injecting harmful data into training sets. And model drift, which is performance degradation over time as real-world data patterns change.
And this is where containment and eradication get truly messy, particularly with large language models. Take an attack like prompt injection. Containment involves input validation and template changes to shield the model. But if the model is fundamentally corrupted, eradication requires retraining it from scratch.
And for these large language models, retraining is often impractical and astronomically costly. So what's the business continuity implication of that?
The implication is profound. If retraining isn't an option, either because of cost, time, or resource constraints, organizations are just left patching a corrupted black box. You have to rely on short-term fixes, like output sanitization, hoping you can trust the system enough to keep it running. For data poisoning, eradication requires isolating and removing the specific poisoned data and then retraining a new model version.
Right.
It's costly, it's time-consuming, and it forces a really hard choice between immediate business continuity and long-term trust in the system.
But on the flip side, AI also presents massive opportunities for incident response. If we use AI for security, we see huge benefits that traditional systems just can't match.
Oh, absolutely. AI-powered IR offers automated analysis of huge data sets, much faster response times, and highly scalable capabilities that are, unlimited by human capacity. It's capable of quicker root cause identification by learning continuously from past events. An AI system can triage thousands of daily alerts and prioritize patching based on actual risk in just seconds.
But the challenge remains managing the potential for inaccuracies or the false positives that AI systems can generate. We can't just turn over the keys to the AI.
Not at all. Human oversight remains absolutely critical. The continuous refinement and monitoring of the AI and the IR process are essential to build trust in its decision-making capabilities. We need the speed of the AI, but we still need the judgment of a human.
This entire deep dive has been, well, a masterclass in complexity. The difference between success and catastrophic failure really seems to rest entirely on the quality of the governance structure.
And if we connect this to the bigger picture, AI governance is a living, continuous process. It's the integration of technical controls like robust asset inventories and data quality checks, with strong ethical frameworks that cover everything from bias mitigation, fairness, and IP management, all the way to transparency and tracking environmental impact.
Yeah, we've learned today that AI is definitely not just another IT system. The unique risks and the high costs associated with systemic failures, I mean, like that 34.7% error rate for certain populations, it makes dedicated governance essential. The necessity for new organizational mandates, you must track environmental impact, you must have an AI ethicist, and you cannot delegate accountability. This proves it's not just a technical shift, it's a huge organizational one.
Which leaves us with a final, provocative thought to consider. The source material noted that one of the most significant gaps today is that AI governance ownership within enterprises is often just unclear. The policies might exist on paper, but if the strategy dictates rapid AI adoption, who is truly responsible for ensuring that policy is rigorously applied in this fast-moving threat landscape?
So as you look forward, maybe consider this. How can your organization definitively clarify ownership of AI governance to close that gap and ensure that trust and security are embedded into every AI decision rather than being an afterthought? Until next time, keep diving deep.